Hello and welcome to another video. In this problem we're going to be continuing on with the TypeScript line 75 and we're going to be doing jump game. And so you're given an integer array nums and you're initially presented at the array's first index, and each element represents the maximum you can jump given that position, so you want to return true if you can reach last index and false otherwise. So in this first example you can jump from here and then you can jump from here and then you can get to the last index. In the second example, you can't do it because no matter where you jump, like let's say you jump here, you can jump here or here, but no matter what you do, you're going to always end up right over here, and then you can't jump from there. So that makes it impossible. So this problem is pretty straightforward once you kind of figure out what needs to be done. So essentially, if you have something like this, what you need to figure out is, can I get to the end? And your jump can be anywhere. Like if you jump too far, then you can just say like I could have just jumped a little bit less, and you have the option like this is like your maximum jump. It's your maximum jump like distance. So jumping past the goal means you can also get there. Like let's say this jump was like 5 and you ended up over here. Well, you could have just jumped less and got here, and that was always an option. So as long as you get to the goal or past it, that is a success. And so the way you could do this problem is actually really straightforward. All you have to do is you just start at the second to last place, so which would be here, and you mark your goal. So let's say that these are indexed, so this is like 0, 1, 2, 3, 4. So we could say our goal is index 4, and we just start at the second to last index and we work backwards, and essentially we just look like, can we get to the goal? And if we can get to the goal, can we get to an index that's before the goal? And if we can get to an index if we can get from our index to the goal, right? So like let's say from here we can get to the goal. Well, then we know that if we can get here, then we also have a success because we can go from here to the goal. So we can essentially just like go backwards, and if we can get from our current location to our goal, that means our goal will be our new current location, because like I said, if we can go from here to the goal, then obviously if we can get here, then we also we have success. So now we can just set our goal to be this value instead. So let's show what that's going to look like. So over here, we're going to start at the second to last index and work all the way to the front. We're going to say, okay, can we get from here to our goal? What's our goal? It's 4. So yes, we can, right? We can jump 1. So then we will set our new goal to 3, because if we can get here, that means we can get to the goal. So this is our new goal. Okay, now we are over here, and we can say, okay, from here, can we get to our goal, which is index 3? Yes, we can, because we can jump 1. So if we can get from here to here, that means this is our new goal now. So we're going to update this to 2, because if we can get here, we know we can get from here to here, and we know we can get from here to here, right? So if we can ever get here, that means we succeed. Okay, what about here? Can we get from here to the goal? Yes, we can, because this is index 1, and if we add 3, we would be there, right? So like I said, it's okay to jump past the goal. If you get to the goal or past it, that's getting to the goal. So from here, you would say, okay, well, our index is 1. We can add 3. That means our index is 4, and our goal is 2. So obviously we can get to our goal. We can just jump a little bit less. So now our new goal would be index 1, and we would be over here, because we know from 3 we can just jump over here, and then that would be successful. Now from here, can we get to the goal? Well, yes, we can, because our index is 0, and we're trying to get to index 1, and we can jump length 2. And so our goal here would update to 0. And then you just check at the very end, like if your goal is 0, that means you've moved your goalpost far back enough to where you've succeeded. Otherwise, no. And let's go through the second case and let's show why this won't work for that one, and the same kind of thing again. Okay, so here we have our goal equals to 4 again, except now our values are different, right? This is now a 0. That's the only difference. Okay, so let's go through this. So we start over here at the second to last one, and we say, can we get to the goal? Well, we can only jump 0, so we can't get to the goal, right? So then we start over here, and we say, okay, can we get to the goal from here? So our goal is 4. No, we can only get to 3, so that wouldn't update our goal. Okay, from here, can we get to the goal? I think this actually needs to, oh yeah, this needs to get updated to 3 and 2. That is the new correct values. There we go, as is in the second example. Okay, so from here, can we get to our goal? Well, our goal is 4. We are at 1, so we can only get to here. So we can't get to the goal. And then from here, same thing, we are at 0, so we can only get to 3, we can't get to 4. So we were never able to move our goalpost back, and our goal stays at 4. And like I said, if in order to achieve your goal needs to move to 0. That's success. So essentially, that's all you do in this problem is you just go backwards and you say, can I get to the goal? And anytime you can get to the goal, you just update your current index to be the goal. Because like I said, jumping past the goal is the same as getting to it because you can always jump a little bit less. So any shorter distance is always going to be like easier to get to. And that's pretty much the problem. Like you just go backwards and you keep updating your goal as you go. And then if your goal equals 0 at the end, you return true. Otherwise, you return false because that means that from 0, you can get to the goal, right? So you would update it backwards, you would keep moving it back, and then eventually you should be able to get there from this 0 element. Okay, so now we can code it up, and here we have our TypeScript, and we're just going to do it in here instead of in the VS Code. So we're going to have a goal, so we can just say like goal, we want to let goal equals the last index, right? That's what we're trying to get to, so we could just say like nums.length -1. And now we essentially have to loop through every element other than the last one, because the last one, it doesn't matter how far we can jump, like we just need to get to the last one. So we're going to loop backwards, so we're going to say like for let I equals nums.length -2. We want to start the second to last element, and then we want to say I is greater than or equal to 0, and then we're going to go backwards, so I minus here. And we're just going to simply say if nums I, right, so whatever number we're at, plus that index, plus I. So like, let's say we're here, we would say, okay, this is index 1, so it does 1 plus 3 get us to the goal. So if nums I plus the index is greater than or equal to the goal, let's update our goal. So then we would say goal equals, this is going to be this new index, and I think that's pretty much it. So we just update our goal, we go backwards, and then we just return goal equals 0. And let's see what happens. See if we did anything wrong. Maybe I missed something. Okay, it looks to be accepted. Let's see. Okay, so that is literally all the code you need. Pretty straightforward problem. You just need to recognize that, like, once I can get from somewhere to the goal, now my new goal is getting to that location because I'm guaranteed to make it from there. And let's think of the time and space complexity for this one. And if you want more practice with this, there's like 7 jump game problems, so you can definitely like do more of these in TypeScript. I think I even have some of the videos for like the harder jump games. They're in Python, but yeah, you can try to do some of those as well if you like, you know, maybe you got this one, but you want to do something harder. Okay, so for the time, we are looping through all our numbers in reverse order, so that's going to be O of n. And then for the space, we are using constant space because we only made like this goal variable. Yeah. And yeah, it's going to be it for this problem, I think. And if you did like this video, it's kind of a short one, but I think it's a good problem to know. And I think it's a reasonably popular interview question. If you did like it, though, please like the video and subscribe to the channel. It really helps grow it a lot. And I think we are almost at 400 subs, so thank you guys for that. And I'll see you in the next one, and thanks for watching.